Hello everyone. 3 days ago, I was browsing through YouTube and came across the man himself's video on simulating an ecosystem. I was instantly hooked, so I set out to make my own. This was never meant to be a challenge or any sort of race, though I completed all of the project's goals within roughly 2 days, so why not add that to the title? I didn't record any of day 1, as I had no idea I was going to go as far as recording and editing a video, but day 2 I pulled in gear and I started recording my milestones. But before any of that, let's first look at how the simulation works. The first step to an ecosystem simulation is life, so I started with animals. I created a scriptable object called the animal settings, which holds the animal statistics like its energy, size, and hunger, as well as its nav agent's radius and height. Through the scriptable object, I can individually set species their own starting stats. I didn't get around to using all the stats, though here are the current functions if you're curious. Once I had the animal stats set up, I needed a base animal object the spawner will use as a prefab for all animals. The prefab contains the animal's UI, the nav mesh agent, as well as the core animal components. The base animal script is a center hub for every animal and houses the animal's current statistics as well as helper functions such as die, spawn, and give birth. The animal AI script controls the animal's AI state using coroutines and logic. Animals can wander around, search for nearby resources, drink, eat, and reproduce. Fleeing and chasing are states I just started working on, but I never actually got them to work, so I'm just putting them to the side for now. The AI first starts by running its initial state, which is default to idle. Idle will calculate how long it should wait before going to the next state by its energy, so the more energy you have, the less likely you are to sit still. After the current state is finished running, the animal will decide what to do next. It will first attempt to search the area for nearby resources, where the search distance is their socialness stat. If a resource is found and the animal craves that resource the most, the animal will go into searching state and move to the resource. Otherwise, it will choose its next state depending on the last. So if the last state was idle, then the next state will be wandering and vice versa. This gives us a continuous loop of randomized, independent movement and stopping. The same logic works with other states, such as searching. When in the searching state, the state will loop until the animal is close enough to the resource. Once that happens, the state ends and the animal will decide what to do next, such as to eat, drink, or reproduce with the resource, depending on what it is. Next, I needed food and water. I did this by creating the base resource component as well as the resource settings scriptable object. Each resource in the world has a base resource component with its respected resource settings. The resource settings includes what type of resource it is, whether it's food or water, and the base resource component is in charge of controlling the logic behind it. Resources can only be gathered by one animal at a time, so every time an animal finds a resource that they want, they must first ask the resource if they can gather it. If the resource responds with a yes, it will go into searching mode and gather it, otherwise it will continue on. At first, water was a little difficult, as I thought to check if the animal was in the water's collider, but that gave me issues I couldn't explain, so I just opted to placing a bunch of water resources around the shoreline and it works perfectly. Now that I had the base animal prefab and the animal AI set up, I needed a way to spawn the animals. I didn't just want to place them in random intervals since that is boring, so I introduced animal spawn zones. With each animal spawn zone, I can configure which species will spawn in it as well as the zone's weight. The weight is used to calculate the chances the species will spawn in that zone versus other zones. The weight system could be useful for larger maps, however in my case there was really no need for it. The last thing I need for my ecosystem simulation is a way to manage everything, so I created the simulation manager. The simulation manager is in charge of storing the current simulation settings, spawning the animals, keeping track of who's alive and who's not, as well as killing the animals. The simulation settings is a scriptable object I created that stores the simulation's properties such as initial animal population, how many of each species will spawn, and the speed of which stats change, such as the age speed. I had to save the best for last, so let's finally talk about reproducing. Just how food and water has a base resource component, animals have it as well, except the resource type is set to mate. When a mature male is looking to reproduce and finds a nearby resource set to mate, it will send a message to that resource asking to reproduce. If the animal is of the same gender, a different species, or isn't mature enough, the process will be cancelled and both animals will continue to their next state. Otherwise, and when the male gets close enough to the female, they are both set to the mating state where they wait a few seconds and bam, a new baby deer. Alright, that's about all I've done with the ecosystem simulation. I could have added a lot more and I may do that and come out with another update video in the future if I feel like working on it again, but I'm very happy with my progress thus far. Of course, I had a lot of setbacks in the process of this project, but most of them weren't recorded, so I didn't include them. One setback I did record was the animal's AI wall detection. Animals kept running into each other as well as the map's bounds, so I added colliders to the edges of the map and wrote some basic logic to turn them around when they were faced with an obstacle. At least it should have been simple, except I had to rewrite a lot of the AI's logic to allow turning around, so it was more like 3 hours. Anyways, it's been fun, bye.